You ever notice how that new app you're excited about or that big website update is always late or over budget or, just a little bit broken? Yeah, it's not your imagination. Building software is, for a lot of reasons, uniquely and incredibly difficult. So what is really going on here? All right, let's get into it and explore the deep-seated challenges and some of the clever solutions that define the world of software project management.
So here's our roadmap for today. First, we're going to define the big problem that everyone in the industry talks about, the software crisis. Then we'll look at how in the world managers try to plan for something they literally can't see or touch. From there, we'll explore the different playbooks teams can follow, and then, we'll dive into the one variable that complicates everything: people. And finally, we'll ask a really fundamental question: what does a successful project even look like?
All right, let's kick things off with a term that's been around for decades now: the software crisis. And yeah, I know, it sounds a little dramatic, but it's a very real thing. It perfectly describes why so many software projects seem like they're doomed from the very start. And if you want proof, just look at this data from the Standish Group. This gives us a really clear, numbers-based picture of the problem. That small green slice, just 29%, those are the projects that are considered a total success. Now look at that massive yellow section, that 52% of projects that are challenged. That means they blew the budget, they missed deadlines, or they had to chop out major features. And that red slice, that's almost 1 in 5 projects that just failed completely. Canceled, gone. The big takeaway here is that struggling, or even outright failure, is the norm, not the exception. The odds are stacked against you before you even write a single line of code.
Okay, so those numbers are pretty stark, but what does this crisis actually feel like for the people who are in the trenches building and using this stuff? What are the common, painful symptoms of a project that's just going completely off the rails?
I'm guessing these symptoms are going to sound painfully familiar. The final product might technically launch, but it doesn't actually solve the user's real problem. The budget doubles, maybe it triples, the launch date just becomes a running joke, and maybe the worst part of all, once it's finally out there, the software itself is this tangled mess, like a digital house of cards that everyone is terrified to fix or even try to improve.
And this really gets to the heart of it all. Why is software just so different? I mean, think about it. We can build massive bridges and skyscrapers with incredible predictability. So why is building a simple app so chaotic? Well, the key difference is that software is intangible. It's pure thought stuff. You can't see progress the same way you can watch a building's foundation being poured. It's also pure intellectual work, which is just wildly variable compared to physical labor. And to top it all off, one tiny change in one corner of the code can cause massive, unforeseen problems absolutely everywhere else.
So if you're managing something that's literally invisible, highly intellectual, and super interconnected, how on earth do you even begin to make a plan? And that brings us to the first huge hurdle: estimation.
Project estimation is, it's basically trying to predict the future. It's all about forecasting the total effort, which translates directly into cost, and the time it's going to take to get across the finish line. But to do any of that, you first have to agree on the size of the thing you're building. And really, how do you measure the size of an idea?
Well, the old school way was to just count the source lines of code, or SLOC. It's simple, sure, but it's also deeply flawed. A much more modern approach is something called function points. Now, instead of counting lines of code, this measures the software's functionality from the user's point of view. How many buttons are there? What reports does it generate? What data does it touch? Think of it like this. SLOC is like judging a novel by its page count. Function points is like judging it by the number of characters, plot twists, and chapters. It's a measure of value and complexity, not just pure length.
Let's really break down why just counting lines is such a trap. First off, coding style. One developer might solve a problem in 10 super elegant lines, another might take 50 messy ones. The feature is exactly the same, but the size is totally different. It also completely ignores all the critical non-coding work like design, research, and testing. And get this, it actually punishes efficiency. A programmer who uses a modern language to do more with less code looks less productive. But here's the real killer. You can't possibly know the final line count at the beginning of the project, which is the only time the estimate is actually useful.
Okay, so getting a handle on the size of the project is the first major challenge. But once you have some kind of estimate, you need a plan of attack. And this brings us to the next big decision: choosing the right process, the right roadmap to actually get the thing built.
Now, broadly speaking, there are two competing philosophies here. The classic is the waterfall model. It's linear, it's rigid, it's sequential.
You finish all of the requirements gathering, then you finish all of the design, then all of the coding, one step at a time. This only really works when you know exactly what you need from day one. On the complete other end of the spectrum is Agile. It's iterative, it's flexible, you work in these small, rapid cycles, building and getting feedback on little pieces of the final product. It's basically built for a world where you know things are going to change and uncertainty is high.
Let's make this more concrete by looking at Scrum, which is the most popular Agile method out there. The work is broken into sprints, these short, intense bursts of work, usually 1 to 4 weeks long. It's a constant loop. Step 1 is planning. The team bites off a small chunk of work from their master wish list. Step 2 is the sprint itself. For that set period, they do nothing but focus on building that chunk. No distractions. Step 3 is the review. This is where they show off the working piece to get real feedback. And step 4, and this is so important, is the retrospective. The team asks itself, how can we do this better next time? And then the whole cycle just repeats. It's a rhythm of build, show, learn, and improve.
So we've talked about metrics and processes, but you know what? Those are just tools. At the end of the day, software is built by people. And this introduces the most complex, the most unpredictable, and frankly, the most important variable of all.
Take a look at this number. It comes from a famous study way back in 1968 where they gave a group of programmers the exact same coding task. The result? The productivity difference between the fastest and the slowest developer was a factor of 25. Let that sink in for a second. One person might finish a task in 2 hours, while another takes more than a full week of work to do the same thing. Now imagine you're the project manager. How do you build a predictable schedule when your key players have that kind of massive variability? It's just a staggering challenge.
And just to add another wrinkle to all this, there's something called the Hawthorne effect. This is a well-documented phenomenon where people's behavior changes simply because they know they're being watched. The very act of measuring a team's productivity can, by itself, increase that productivity. It means your management data is never perfectly objective. The measurement process itself is influencing the outcome. So who are we managing all this for? The stakeholders. And that term is way broader than you might think. It's not just the customer or the boss. It's everyone with a vested interest in the project's outcome. The project manager trying to stay on track, the developers building it, the executives who are funding it, even outside vendors. And guess what? Each one of them has a slightly different definition of what success actually looks like. Which brings us perfectly to our final section. With all of these chaotic, moving parts, how do we even track our progress? And ultimately, how do we define a quality product at the end of it all?
Well, one of the classic tools for tracking a plan is called the critical path. In any project, some tasks depend on others, right? You have to pour the foundation before you can build the walls. The critical path is just the longest chain of these dependent tasks. It represents the absolute shortest time a project can possibly take. A one-day delay on any task on this path means a one-day delay for the entire project, which is why managers watch it like a hawk.
So, let's say we do it. We hit our deadline on the critical path. Are we done? Is it a success? Well, the traditional view of quality for pretty much any product is something called fitness of purpose. Basically, did it do what the specifications said it would do? For something like a toaster, this is really easy. If it makes toast, it's a quality product. Simple.
But here's the crucial question when it comes to software. Is that really enough? What if a program does everything it's supposed to on paper, but it's painfully slow, it's confusing as heck to use, and it crashes twice a day? Can we really call that a quality product?
And this reveals a much more complete, more nuanced picture of software quality. Correctness, does it work? That's just the price of entry. A truly quality product also has to be reliable, so it doesn't fail on you. It needs good usability, so people can actually figure it out. It has to be maintainable, so fixing a bug later doesn't require a total rewrite. You've also got to think about things like portability and efficiency. Success isn't just a single checkbox, it's a careful balance across all of these different attributes.
And that brings us right back to where we started. The incredible difficulty of building software isn't really just about code. It's about planning an invisible product, choosing a process that can withstand constant change, and managing the profound, unpredictable variability of the human mind. All the tools and all the methodologies we've talked about are just attempts to bring a little bit of order to that inherent chaos. Which leaves us with one final thought to chew on. Is the software crisis a temporary problem that we can eventually solve, or is it simply the permanent condition of an industry that's trying to build castles in the air?